Yes, yes, yes.
Now we will see what are those core data types or core objects. I have told you Python is all about object. I have already told you what is object. I gave examples also. Now Python has some core object types. With those object types, we can build hell number of objects. You can do any kind of work. But these core object types are very much important. You should know those core object types before doing anything. So that's why this is very, very, very important topic for the Python. So object type on left side and another side literal. Literal means, so before I explaining that, I have to give one example from, yeah. Hello.
Yeah.
Okay, so before I explaining this, for example, if you want to declare, if you want to assign a variable, a value to a variable, if it is a C language or a Java, what you have to do is you declare what type of variable it is, whether it is variable or not. On other side, what it is, whether it is int or float, or that also you have to tell, you have to say to your machine. Whereas Python, you don't need anything. If you just type one, just one, then your system understands that this is int. If you type 1.1, the system understands that this is float. If you use square bracket, the system understands that this is list. If you use parenthesis, the system understands that it is tuple. If you use curly bracket, the system understands that this is dictionary. So every object type has certain syntax so that the system can understand. That is called literal. A literal is one which can create an object. It is an expression which can create an object. So now you got the literal. What is literal and what is object? Now we will see the core that objects. So what is the first one? Numbers. Obviously, in any language, whether it is a daily like spoken language or whether it is a programming language, the building blocks should be remain same, because whether it is a programming language or any type of language, finally what it has to do, it has to communicate with a human. We are not doing for the aliens, we are doing it for us. So it has to communicate with us. So obviously we have to use the same components that we use in daily life. So numbers. So the first thing is number. That is, these are the example I have given. Later we'll see the numbers are also subdivided. Okay, first we'll see numbers. Number. Of course, number is not an object. In numbers, there are few objects: int, float, complex number, decimal, fraction. So now strings. So that is a second object. Next, list. See, what you have to observe here is one, what are the core object type names, and second one is literal or the expression, how that expression looks. The expression that actually makes list is use square bracket, and the expression that actually makes string is use single quote or double quote or triple quote. That's what you have to observe here. And the third one is dictionary. For this, what you require is a square, a curly bracket with key and value pair, and a tuple, parenthesis, files. This is a little advanced topic that we'll see later, but to create a file or to interact with a file, to communicate with a file. This is how you have to write the what you call the literal or expression for the file is this. See sets for set either one you can use, either expression you can use, either a curly bracket or directly set as a call option. And other core types. These are also object. Boolean is an object. Boolean is not an object. Bool is an object. True or false. And types. Types is nothing but list of, list of, tuple of. These are all types. These are also object. None. None means nothing. There won't. It doesn't. It will take a space. Obviously, it will take a space, but it isn't empty. There is nothing will be stored. That's a none object. None is also an object. And finally, program unit types. Function is also an object. Module is also an object. Class is also an object. That's what I'm saying is Python is all about objects. Now, lastly, compile code and stack tracebacks. So why I have introduced some fundamental terminology such as object, expression, statement, module, program. Why? Because so that I can use those terminology ahead, or else it's difficult to understand. See, whatever left side, right side you are looking at, these are all called expression. What expression does? It creates something. That's what. So left side is list names. Those are just object names, but right side you have to focus. Those are expressions. So by and large, Python is all about this only. Other than this, there is nothing. If you want to create more, that's a different aspect. But inbuilt, inherently, this is what Python is. These are all objects. You can make new objects. That is all up to you. But what that comes up with Python is this. For example, Chaitu, if you take English language, we are creating a lot of words now. Not letters, but we are creating words or not. We are making I think every 5 years, they're adding new words, new expressions into this. Similarly in Telugu, Jaffa, where is Jaffa came? Where is Daffa came? Where is Maffa came? We are creating like that in Python. We can make a lot of objects, lot of new objects. It is as similar to our language. So this is all about the core data types. Now we will briefly discuss each object one by one, but it's clear. Just recollect the fundamental or core objects. Okay, numbers, strings, lists, dictionaries, tuples, files, sets, and bool, types, none, functions, modules, classes. Just remember this. This is all about Python. It is not something else. Once you have this clarity, then it doesn't seem like a rocket science. So now, as we decided before, we'll start with the numeric literals. Literal, I have told you, it is an expression to create an object. And then what does it mean? So numeric type, most of the things you know. First, we'll begin with integers of unlimited size. It can be negative, it can be positive, or it can be 0. It can be unlimited. Any number of numbers we can add. What is the expression for it? Nothing doing. Nothing. Just put 1, 2, 3, 4, or 24, minus 24, 0, or 999. When you give it like this, the system or the machine understands this as a int. Int. The second one is floating point number. Just what is the literal or expression for this? What is literal expression for this? In spite of giving 1, 2, 3, 4, just add a decimal. It will understand it as a floating point. 1, 2, 3, 4.0. If you put it, it takes it as a integer. If you don't use decimal, then it will take it as a, sorry, if you put decimal, it take it as a floating point number. If you don't use decimal, it take it as an integer. So as we decided before, it is of discussing theory aspect. It is not adding practical. See, because that's why we are not using any kind of uh, interpreter or Visual Studio Code, something like that to code. First, we should get the theoretical knowledge or rules and the set of rules. Then we can actually code. So here we have seen integers and floating point numbers, objects, int, float. And second one is octal, hexadecimal, and binary literals. What is the expression? 0, wo, and any number if you put, that is octal. If you use 0, x, and anything after that you put, it takes it as a hexadecimal. If you put 0, b, after that whatever you put, it takes it as a binary literal or binary object. Clear? So then what left is complex numbers. For complex number, anyway, it can take int, float. It takes both. So either you can give 3 plus 4g or 3.0 plus 4.0g or just 3g, 3j. So whatever you can, that's the complex. To create a complex number object, this is the expression we have to use. Got it? So now Booleans are also considered into numeric literals only. They are also comes under this because true or false, what it is, 0 or 1. Clear? 0 or 1. So then it's a numeric. That is the reason in Python, Boolean true or false also comes under. See, for you it's a true or false, but for it is, for system it is zeros and ones. So that's why they have consider it as numeric literal. Next, set also comes under numeric literal because most of the operations that you do are mathematical. That is the reason set also comes under numeric literal. So these are the numeric type objects. Numeric type objects. These are all core objects. What are those? Int, float, octal, hexadecimal, binary, complex, Boolean, set. These are all objects only. These are all core objects. Each has their states. Each has their behavior. You can do a lot of, for example, if you take set, set has plenty of methods. Set has one shape. Set has one states. So each is an object. So these are the objects that belongs to the numeric category. So here I've also mentioned like you can use built-in calls to create or to convert. Got it now? If you type hex and give some other number, it will convert that number into hexadecimal. Okay.
Yes.
Then, in addition to this, Python also provide, these are the core objects. In addition to this, Python also provide certain objects. See, these are the expression operators, plus, minus, and all those stuff. And built-in mathematical functions. These are functions. Functions are made of, again, statements only. But these are functions. And we have a modules. These are built-in modules. Clear now? Whatever we are talking about is core object. Int, float, octal, hexadecimal, binary, complex, Boolean, set. And whatever now, in addition to that, we also have more tools to do the mathematical operations. Those are either it may be power built-in functions, that is power absolute around int hex bin, or maybe modules. Obviously, these modules are also made up of the objects only, na? But they made it before for the simple uses. Then the next thing we'll discuss is Python expression operators. So here we have seen the last one, Python expression operators. So this table is highest precedence with highest precedence. Just we don't discuss completely. We'll just have a brief view. So the first one is double asterisk is for the exponentiation. Plus or minus, plus is for addition. Most of the things you know, but still as a brush up. Addition, minus is for the subtraction. And we have a asterisk for multiplication, forward slash for division, and this is modulus operator for modulo, and double forward slash is for the floor division. Okay. Then these are comparison operators, less than or equals to, less than, greater than or equals to. And these are equality operators. These are for the equality of less than, greater than. So next, assignment operators. Equal is an assignment operator. Similarly, we can have module equal, forward slash equal, minus equal, and plus equal. So with this also possible. And is not. These are identity operator. And in, not in, these are membership operator. For example, we can use this in loops for X in this list of. So like that we can use it. We can also check whether some object is in this object or not. That is membership operator. That's why it's called membership operator. And final one is logic operators, and or not. So this is the actually precedence. The asterisk, that one will have a highest precedence. If you use parenthesis in this, so basically it will have a highest precedence. So here